Hi everyone, so I just wanted to give you the answers to the activities that you did for your last lesson, so activity 7 to 12. This is activity 7, so after you'd watched the video about Boscastle, hopefully you didn't find this too difficult, especially because you'd got the missing words at the bottom. So the completed missing word activity is there for you to look through. So it says that the Boscastle flood was an intense storm event. It was produced as a result of warm, moist air from an ex-Category 2 hurricane which had moved eastwards over the Atlantic Ocean. So it was the remnants of a Category 2 hurricane. This air, upon reaching Cornwall, rose over the 400 metres high Bodmin Moor, cooling and condensing to form orographic or relief rainfall. So that air was forced upwards, cooled down and condensed and formed that rainfall. At that time, Boscastle was also located at the centre of a convergence zone as two air masses moving in opposite directions converged, forming frontal rainfall. So you'd got lots of warm, moist air being pushed over from the Atlantic, and you'd also got that air trapped over Boscastle in that convergence zone, causing that frontal rainfall. The dual effect of those two types of precipitation resulted in the intense precipitation. Around 75 millimetres of rain fell in 2 hours, which is the same amount that normally falls in the whole of August. So I got a month's worth of rainfall in just 2 hours. At the peak of the downpour, 21.4 millimetres of rain was recorded as falling in just 15 minutes. So that's a large amount of rainfall. The torrential rain led to a 2-metre rise in river levels in just 1 hour, which led to devastating flooding. For activity 8, this was an evaluative discussion, so it wasn't a question as such, but it was helping you to develop your evaluative answers in reference to specific case studies. The question was to what extent, the command word here is to what extent, and it was asking you to what extent was the flooding in Boscastle a factor of intense rainfall. The command to what extent requires that you, first of all, provide evidence that flooding was a factor of intense rainfall, so consider the factor that's been given to you in that answer. Then, because you're balancing your answer out and you're considering the extent to which that rainfall had an impact on the level of flooding, you then have to provide evidence that other factors played a role. Part 3, you can do this either throughout or at the end of your answer. You then have to summarise the extent to which each factor was important. As I said in my PowerPoint I sent originally, was it just the rainfall? Was it just the other factors? Was it a combination of all of those factors and the rainfall? Was something more important to start with or more important as the event went on? Something a catalyst, etc., etc. So I'm not going to read the answer to you, but you can pause the PowerPoint at this point and you can see that this answer first of all starts off talking about the rainfall and the causes of that rainfall and how that led to the flooding. But then second of all, it goes on to look at the other factors which contributed to the flooding, and then at the end weighs up what was most important. So you then had to move on to look at another factor which leads to excess runoff and potentially flooding, and the next factor was another natural factor, which is snowmelt. You had a little video to watch about this case study, so the Red River and the flooding that occurred in 2009. Once you'd watched the video, you then had an activity where you had to annotate the diagram below, which is kind of indicating the change in that river basin after the snow event, to show how the rapid snowmelt led to excess runoff and flooding. So if I just talk you through the normal conditions, first of all, I'm going to try and highlight the key terms as I go through. You can then see how those processes are affected when you've got snow melt and frozen ground. So under normal and frozen conditions, soil is permeable, okay, so water can infiltrate into and percolate downwards through the soil, as you can see in the arrows on that diagram. Most water will enter the river by the relatively slow processes of through flow and base flow. Okay, and I should have also highlighted the words infiltrate and percolate. So most of that water, once it's moved down in the soil, either into the top layer or down into the groundwater, it's going to move relatively slowly through that soil towards the river basin. Consequently, the discharge of that river will change slowly, and peak flow following a precipitation event will be relatively low. Okay, so it's going to take a long time, a relatively long time, for that water to get into the river. It's going to kind of constantly feed that river. When snow is, if you look on the other side of the diagram now, when soil is frozen, it then becomes impermeable, and the reason for that is that ice fills the pore spaces, so water can no longer enter that ground. If rapid snowmelt takes place, like it did in the Red River case study, so temperatures increased quite quickly, infiltration is restricted as the ground remains frozen for a short period of time, doesn't thaw out as quickly as the snow, and thus the meltwater will be forced to become surface runoff. So no meltwater can move into the ground through infiltration, no more water can move from the ground into the groundwater store through percolation. Consequently, water will enter the river rapidly because it's just melting and running straight off, as you can see in that diagram. And because of that, the effect will be that there's a quick rise in discharge and a high peak discharge. If bankfull discharge, so the amount of water that the river can hold, is exceeded, a flood will occur. So if you looked at the flood hydrograph for the Red River, you'd see that bankfull discharge was exceeded and therefore flooding did occur. So you then moved on to the first human factor and the only human factor that you looked at last lesson, and this is activity 11, using the diagrams to complete the table to show a summary of the effects of deforestation on runoff. And you were looking at a forested area compared to a deforested area. If you have a look at the table, you've got a range of different factors or effects. So the first effect was the quantity of precipitation reaching the surface. Now, in the forested area, this is lower because of increased levels of interception loss. Okay, so in the forested area, you're going to get lots more interception compared to a deforested area, and you're therefore going to lose more precipitation through that process of interception loss. And it's going to be held on that vegetation before it's lost for a long period. Compare that to a deforested area, it's obviously going to be the opposite, so that's higher because you've got lower levels of interception. And you can see on the diagram over here, to the right, that you've got less vegetation, therefore less interception. If we then move on to the next effect, the amount of infiltration, in the forested area, this is higher. This is because tree roots create macropores in the soil. So if you think back to Unit 1, where you were looking at all of those processes, you learnt about this in Unit 1. Got more infiltration in the forest because you've got the tree roots creating those macropores. You've constantly got those pore spaces sort of emptying out of water because the trees will take in that water. So therefore you've got a constant cycle of infiltration. On the deforested area, you've got less infiltration. So this is not looking at an area which has become urbanised from that diagram, but you've still got lower levels of infiltration because you've got compacted soil. Which has reduced the pore spaces in the soil. It's sort of literally flattened them down, and there's less room in that soil for the water to move into. If we then think about the level of the water table, it links to the point above. So for the forested area, you've got more water, high level of water in the water table, because if you've got increased infiltration, you're then going to have more percolation. Obviously, again, opposite on the other side, so in the deforested area, you've got less infiltration, so therefore you've got less percolation. Okay, I'm sorry about my highlighting, I can't actually see it when I'm clicking, I can only see it once I've saved the animation. So 2 more factors or effects to think about. The return of moisture to the atmosphere. This one links to the top factor and another factor. So in the forested area, you've got higher levels of moisture being returned to the atmosphere. This is because you've got increased levels of plant uptake, so you're then going to have more transpiration. As I said, at the top, you've also got more interception, so you're going to have more, that should say interception loss, not infiltration loss. You're also, therefore, going to have higher levels of evapotranspiration. So more water is lost either from the trees going through the process of photosynthesis and transpiring that water back into the atmosphere, or losing the water through interception loss. Obviously, that's then the opposite for the deforested area, because if you've got less vegetation cover, you're then going to have less transpiration, you're then going to have less interception. Last of all then, just linking it again back to how you could visually represent this in graph format, the shape of the hydrograph for the forested area is going to be less flashy, so it's going to take longer to respond, it's going to have more of a long lag time, it's going to have a lower peak flow, it's just going to be a kind of gradual hydrograph, everything's kind of moving much more gradually through that river system. For the deforested area, you're then going to have a more flashy hydrograph because most water is going to reach the river channel via the relatively fast process of surface runoff. If it can't infiltrate, there's less vegetation to intercept it. There's therefore going to be more surface runoff. So have a look at your answers, compare your answers, maybe add detail or change things if they were a little bit different. You didn't need to, as I said, talk about urban areas for this one. It's just purely a deforested area compared to an undisturbed forest. Okay, so final activity that you had to do was still about deforestation, but this time it was looking at a different location, so Haiti. You've looked at Haiti before in your tectonics unit, and you're going to come back again to think about Haiti when you do the weather and climate topic, because one of the topics within that topic is the idea of tropical storms and hurricanes. So this is what we call a synoptic topic. What you learn in water and carbon, you can transfer over into your weather and climate unit when you study it in year 13. This is similar to a data response question, so you've got a range of different bits of data from different sources, some numbers, some diagrams, a map, some little sort of graph kind of things at the bottom, and you can see that the answer here has basically just used that information to answer the question. Okay, so you had to summarise how deforestation has increased the risk from these precipitation events. 2 key things you had to reference in your answer, so evidence of deforestation was one, and then where's the explanation of how it increases that risk? That's the second part of your answer. So as you can see here, the first bit of the answer is giving you some evidence. It says that in 1923, 60% of Haiti was covered by forest. But as a result of deforestation to create farmland, just 4% remains. Okay, so there's your evidence of your deforestation and the reasons for that deforestation. You then had to think about how that's increased the risk. So the effect of that is that it reduces interception. It also reduces rates of infiltration, which then increases levels of surface runoff. Because of that, when you have storm events, an increased proportion of precipitation reaches the river channel and does so more rapidly. It then goes on to talk about what else deforestation occurs. So first of all, the rainfall will reach the river channel more rapidly. Second of all, it exposes the soil to increased soil erosion. The particles there of that eroded soil will add to the volume of sediment within the river channel, which in turn raises river levels further. Okay, so basically I started off kind of highlighting little bits, but pretty much all of the rest of this answer is giving the reason for that flooding, that increased risk of flooding. You've also got increased urbanisation, which not only increases surface runoff, but it also increases the vulnerability of people to the risk. Because if you haven't got people there, then you're not going to have a high risk to life. If you've got more people there, you're then going to have an increased vulnerability of those people to the risk from those tropical storms. And evidence that there is a risk is that 800,000 people were affected in the country in 2008 in their hurricane season.